So we'll continue with the polynomials part 3. Okay. So we have now know how to find the zeros of the polynomials, and from the zeros how to write the polynomial. Okay, we have studied about that. Now we will try to see the graphical representation of the zeros, and we will try to understand more about the zeros of the polynomial. Okay. Now, consider one equation y is equal to 2x plus 3. Consider one equation y is equal to 2x plus 3. Okay. And when you plot the graph, when you plot y is equal to 2x plus 3, so this is the graph what we are able to see. Y, this is minus y, x and minus x axis. So here we can see this point is what when x is equal to 0 and y is equal to 3. And this point here it is minus 3 by 2 comma 0. Okay. So what does this point indicates? This point actually indicates the 0 of the polynomial. This point actually indicates the 0 of the polynomial. Okay. Why it indicates the 0 of the polynomial? Because see here, y value is 0 here and x value is minus 3 by 2. Correct? So here, if I put x is equal to minus 3 by 2, the whole function value, you will get it as 0. That is only 0 of the polynomial, no? What we studied, right? So graphically also, you can find the 0 of the polynomial. Graphically also, you can find the 0 of the polynomial. Okay. So if I substitute minus 3 by 2 here, what you will get? Y is equal to 2 into minus 3 by 2 plus 3. So y is equal to 0. That means what? At x is equal to minus 3 by 2, you are getting y is equal to 0. So that is the 0 of the polynomial. So from the graph also, you can find the 0 of the polynomial. Again, I repeat, see from the graph also, you can find the 0 of the polynomial where it will be, the point will be on the x-axis. The point will be on the x-axis. Okay. And another one, see here how many zeros you are able to see in the graph? Only one. Okay. So what does it indicate? Whenever the degree of the polynomial is 1, then the 0 of the polynomial is also 1. That means how much will be the degree of the polynomial, that many zeros you will have. Okay. See, again I repeat, how many what will be the degree of the polynomial, that many zeros usually you will have. That is, for example, if I consider any other equation, here it is a quadratic equation, right? So in a quadratic equation, you will have two zeros. Okay. So what is the degree? What do you mean by degree? It is the highest power of the polynomial. So what will be the degree? That many zeros you will have. Okay. If you want, you can just write this and just write as a hint note. The number of zeros will be equal to, the number of zeros will be equal to, will be equal to degree of the polynomial. Will be equal to degree of the polynomial. Write down the second one. Y is equal to x square minus 3x minus 4. Okay. Now can you tell me what are the zeros of this polynomial?
0, no, my
4 comma 0. Another one is minus 1 comma 0 you will get. Correct? That means x is equal to minus 1 and x is equal to 4 are the zeros of this polynomial. Okay. So they will ask the MCQs in that. They will give the graph. From that you have to tell how many zeros are there or what is the value of x where it is in 0. Okay. Huh. Now consider example 1. Example 1 in the page number 17. Page number 17 in your book, example 1. The first one. Can you see the graph? First one. How many zeros are there? 1 0 is there. You have zeros. Second one in the 2 zeros are there. Third one, 3 zeros are there.
second one, 2 zeros.
2 zeros. Third one, 3 zeros. Why it is 3 zeros? Because at 3 points it is intersecting the x-axis or touching the x-axis. Okay. What about the fourth one? 1 0.
So we take only if it touches the x-axis.
When it touches the x-axis, that means at that point y is equal to 0. Correct? When it touches the x-axis, y will be equal to 0. That means that is the point. That is the 0 of that polynomial. Fifth one, 1. Sixth one, 4 are there. 1, 2, 3, 4. So we'll have 4 zeros. So understood, no? Write down this and start with the exercise 2.1. So these questions it will come for like in the MCQs, 1 mark question they will ask. Question, how many zeros are there? 0. So you don't have any zeros there. Yeah. Second one, 1 0. Third one, 3 zeros. Fourth one, 2 zeros. Fifth one, 4 zeros. Correct. Sixth one, 3 zeros. verify the, write down, verify the 3 minus 1 minus 1 by 3 are the zeros of the cubic polynomial, of the cubic polynomial p of x is equal to 3x cube minus 5x square minus 11x minus 3. Then verify the relationship between the zeros and the coefficients and the coefficients. So you have to verify whether 3 minus 1 minus 1 by 3 are zeros of cubic polynomial or not. Okay. So put first x is equal to 3. Instead of x, put x is equal to 3 here. So you will get 3 into 3 cube minus 5 into 3 square minus 11 into 3 minus 3. So what you will get? 3 into 3 cube, 3 3s are 9, 9 3s are 27. So here it is 27 minus 5 into 9 minus 11 into 3, 33 minus 3. So what you will get? 3 into 27, 81 minus 5 into 9, 45 minus 33 minus 3. See, all the like negative numbers add once, then direct do the subtraction. How much you will get? Minus 45 minus 33, 81, correct. So we'll get it as 81 minus 81. So P of 3 is equal to 0. So that means what? 3 is a 0 of this polynomial. It is verified. Then check with the P of minus 1. What you will get? P of minus 1. Instead of x, put value as minus 1 and check. 3 into minus 1 whole cube minus 5 into minus 1 whole square minus 11 into minus 1 minus 3. Okay. Minus 1 whole cube. What will be the value? Minus 1. Why? It is minus 1 into minus 1 into minus 1. Minus into minus plus into 1 you will get into minus 1. So plus into minus will be minus, so you will get it as minus 1. So you will get it as 3 into minus 1 minus 5 into plus 1 minus into minus plus 11 minus 3. Now here you will get minus 3 minus 5 plus 11 minus 3. So what will be the answer here? 0 you will get. Now P of minus 1 by 3. What you are getting the answer? P of minus 1 by 3? 0 you are getting. So 3 into minus 1 by 3 whole cube minus 5 into minus 1 by 3 whole square minus 11 into minus 1 by 3 minus 3. So what you will get here? Minus 1 by 3 minus 11 into minus 1 by 3 minus 3. So 3 and 3 we can cancel here. Minus into minus plus, plus into minus, minus. We'll get it as minus 1 by 9. Here minus into minus will be plus, plus into minus will be minus. So we'll get it as 5 by 9. Minus into minus plus 11 by 3 minus 3. So here, what will be the LCM? LCM for 9, 3 and 1, it will be 9. We'll get it as 9 by 9 is 1. 1 into minus 1 will be minus 1. Again 9 by 9 is 1. 1 into minus 5. It is minus 5 here. 9 by 3. 9 by 3 will be 3. This 3 you have to multiply with 11. So you will get it as 33. Next, minus 3 is there. 9 by 1 is 9. 9 into 3. 9 into 3, 27. What you will get? 28 plus 5. It will be 33. So minus 33 plus 33 by 9. So P of minus 1 by 3 is equal to 0. So now we have verified that all the 3 minus 1 by 3, all the 3 are the zeros of this polynomial. Okay. Hence 3 minus 1 by 3 are the zeros of the polynomial. Okay. Next, he is asking to verify the relationship between the zeros and the coefficients. The polynomial is what? P of x is equal to 3x cube minus 5x square minus 11x minus 3. Correct? So, here in the standard form, if you write, you can write it as ax cube plus bx square plus cx plus d. Correct? When you compare, a is equal to 3, b is equal to minus 5, and c is equal to minus 11, d is equal to minus 3. Now you have to verify the relationship. What we have, alpha plus beta plus gamma will be equal to what? Minus b by a. Alpha plus beta plus gamma is equal to minus b by a. Here 1 0 we will take it as alpha, that is 3. Beta is equal to minus 1, and gamma I will take it as minus 1 by 3. Okay. So if you add together, that should be equal to minus b by. Verify. Now, even with alpha, beta and gamma, they can give in the CBSE questions. Okay. So alpha plus beta plus gamma. So what you will get? Alpha is equal to 3 minus 1 minus 1 by 3. Again, you have to take the LCM will be 3. LCM by denominator will be 3. 3 into 3, 9. Minus 3 by 1 is 3. 3 into minus 1 is minus 3. Correct? Next, 3 by 3 is 1. Here it will be minus 1. So you will get it as minus sign, which we will add it once. 3 and 1 is there. So 9 minus 4 by 3, will get it as 5 by 3. Okay. Minus b by a. Minus b is what here? Minus 5 by a is 3. So minus b by a is also equal to 5 by 3. So it is verified now. Therefore, alpha plus beta plus gamma is equal to minus b by a. It is equal to minus b by a. Next, alpha into beta plus beta into gamma plus alpha into gamma. Alpha into beta, two terms you have to multiply together. Alpha into beta plus beta into gamma plus alpha into gamma. Huh. So that is equal to what? C by A. Okay. Now put the values. Alpha 3. 3 into minus 1 plus minus 1 into minus 1 by 3 plus minus 1 by 3 into 3. Minus 3 plus 1 by 3 minus 1. Okay. Minus 3 minus 1, I can take it as minus 4 plus 1 by 3. Again you will get minus 12 plus 1, that is minus 11 by 3. Okay. Now C by A. C is what? Minus 11 and A is equal to 3. So again, therefore, alpha into beta plus beta into gamma plus alpha into gamma is equal to C by A. So this is also verified. Actually, you have to get it equal, the coefficients, okay, and whatever with the zeros. You are finding the relationship, it will be always true. Okay, if you are getting this much, then whatever you have done, that will be correct. If you are not able to verify, that means somewhere you would have done some mistake. Even in the exam, you can verify. Okay. Next, alpha into beta into gamma. Alpha into beta into gamma will be equal to minus d by e. And if you observe, first you will get minus here, then plus, then minus. Okay. Alpha into beta into gamma. That is 3 into beta is what? Minus 1 by 3. Gamma is 1 by 3. Then beta is minus 1. What you will get? You will get it as plus 1. And minus d by a. D is minus 3, no? D itself is minus 3. So minus of minus 3 by 3. So minus d by a will be equal to 1. Again, we are able to verify that alpha into beta into gamma is equal to minus d by a. Okay, understood? No, you have to by heart that relationship. What we have, alpha plus beta plus gamma is minus b by a. Alpha into beta plus beta into gamma plus alpha into gamma is c by a, and alpha into beta into gamma is equal to minus d by a. Okay. And whenever you verify, the relationship will be always true. It will be always true. Okay. Sometimes they ask 2 to 3 mark questions. So this actually we have finished the NCRT thing problems. We will do some RS Agarwal problems from this chapter. Okay. If the product, if the product of the zeros, if the product of the zeros of the polynomial ax square minus 6x minus 6 is 4. Find the value of a. Find the value of a. Okay. But they have given, if the product of the zeros of the polynomial is 4. Product of the zeros means what? Alpha into beta. Product. That is equal to 4. Now find the a value. You have to find the a value here. So alpha into beta is equal to what? Alpha into beta. C by a. Correct. Now, so alpha into beta is equal to C by a. Now, A is equal to what? Here we have standard form ax square plus bx plus c, correct? When you compare that, what is A, or the coefficient of x square? Equal to A only here. What about B? Minus 6. C, it is minus 6. Now alpha into beta is 4. Now this is equal to, what is C value here? Minus 6. And A value is A. This is minus 6. Okay. So what you will get? 4A is equal to minus 6, or A is equal to, since 4 into A it is multiplication, when it transpose you will get it as a division, correct? So you will get it as minus 6 by 4. Divide, we can divide by 2 here, we'll get minus 3, and here 2. So A is equal to minus 3 by 2. Okay, this type of questions they will ask. Okay, 1 mark or 2 mark questions. Many times it will come in the exam. This type. This is also exam question only. In 2009 they have asked this question. Okay. Write down that second question. If alpha and beta are the zeros of the quadratic polynomial, f of x is equal to x square minus 4x plus 3. Find the value of alpha to the power of 4 into beta square plus alpha square into beta to the power of 4. Find this. Try this. This is also exam question only. Okay, so what and all we are doing now are the different exam questions, so that you will be able to know how the questions will come. So we know alpha into beta, alpha plus beta, and the polynomial, correct? All these we know now. Now think how I can get the value, that value. Okay, there are two ways to do this problem. Okay, one method. Now we have alpha to the power of 4 into beta square plus alpha square into b to the power of 4 is there. I will take alpha square, I can take common here, and beta square. Here also I can take alpha square and beta square. So if I take common alpha square and beta square, see here, if I take common, what you will get? This will be 2. Alpha square you will get inside plus here alpha square into beta to the power of 4 by alpha square beta square. Beta square you will get, correct? So this I can write it as alpha into beta whole square into alpha square plus beta square is there. See, a plus b whole square, this listen carefully, many times you have to use this method only. Sometimes the question will be such a way that you will be not able to find alpha value, beta value directly. Okay, then you have to use this method itself. Okay, a plus b whole square is what? A square plus b square plus 2ab, correct? So a square plus b square will be what? If I shift 2ab to the other side, you will get a plus b whole square minus 2ab. I can write like this, correct? So here alpha square plus beta square, I can write it as alpha plus beta whole square minus 2 into alpha into beta. Okay, now alpha plus beta is what? Here minus b by a, right? You will get it as 4 by 1. So alpha plus beta is 4. Okay, then alpha into beta, c by a, that is 3 by 1, it is 3. Okay, so alpha into beta, I can write it as 3 square. Alpha plus beta is 4, 4 square minus 2 into 3. 3 square is 9, 4 square is 16 minus 2 into 3 is 6. So you will get 9 into 10. Okay, so alpha to the power of 4 into beta square plus alpha square into beta to the power of 4 is equal to 9. This is one method. Write down this. Everyone write down. Find the value of k. Find the value of k such that the polynomial x square minus of k plus 6 into x plus 2 into 2k minus 1 has sum of its zeros equal to half of their product, equal to half of their product. Huh. Try this. So they have given the polynomial, you have to find x, and they've given the condition sum of its zeros. Sum of its zeros means alpha plus beta, correct? That is equal to half of their product, half of alpha into beta. So here, what is the polynomial they have given? X square. Listen here, x square minus of k plus 6 x plus 2 into 2k minus 1. Okay. So what you will get if you compare with ax square plus bx plus c. A is equal to 1. B is equal to, this whole thing is b. This into x is there, right? So minus of k plus 6. So b is equal to minus k minus 6. Okay. What is c here? 2 into 2k minus 1. It is whole thing is a constant. Okay. Now alpha plus beta is equal to minus b by a, correct? And alpha into beta is equal to c by a. Alpha plus beta is equal to minus of this thing, minus of minus k plus 6, correct? By a is equal to 1. So alpha plus beta is equal to minus into minus plus k plus 6. And again alpha into beta is equal to c by a, 2 of 2k minus 1 by 1. Okay, k plus 6. No? See, minus is outside. So minus is for both. We have taken common and it's given. Minus of k plus 6. Here it is minus b by a. So this is minus and b itself is this much.
But b is minus k minus.
If you take common, what you will get? K plus 6. It's the same thing you will get. Okay. So alpha plus beta is k plus 6. Alpha into beta is 2 into 2k minus 1. Now what is the condition they have given? Alpha plus beta is 1 by 2 of alpha into beta. So I will write k plus 6 is equal to 1 by 2 of 2 into 2k minus 1. 2 and 2 I can cancel. K plus 6 is equal to 2k minus 1. Okay. Now k I will transpose to the other side. So here plus k will become minus k. 6 is equal to 2k minus k minus 1. Correct? Now simplify. Write all this. We have 6 is equal to 2k minus k minus 1. 6 is equal to 2k minus k is k minus 1. Minus 1 you shift to the other side, it will become plus 1. So k is equal to 7. Okay, k is equal to 7. Got the same thing? Okay, tomorrow we'll continue.